So I think many of you are working as a piping engineer. So we know that in a piping department, we have three subgroups. The larger subgroup is a piping layout, larger in the sense the number of engineers working in one project. So in piping department, we have three subgroups. First is a piping layout. Second, piping material engineer. And third, piping stress analysis engineer. So in market, many of us, when we talk about the piping engineer, many of us are just talking about the piping layout engineer from modeling point of view. But at the same time, we do have two different departments: piping material engineer and piping stress analysis engineer. And I think these two groups are considered as a core group of a piping, because it's purely on a technical knowledge they work. So today we are going to have an overview of the activities carried out by a piping material engineer, as well as a few aspects of piping specification or the piping material, we can say. Okay, so I'll start with the session. If you guys have any questions, we will take at the end of the session. Yeah.
हाँ लागला
Okay.
ठेव चंद्र बोल.
Okay. So what is a piping material engineer? So as we all know, anyways, we all are working. Okay, I'm sorry if few things are very common and at the basic level, because this session is targeted for everyone. So there might be a fresh college graduate student who have no idea about the piping, as well as there are just the junior engineers who have started in this industry. So I have included a few basic concepts also. So this might be repetitive for this, but being a larger audience, we have to, make the common content for this presentation. So as we all know that piping does not means only a pipes. It also includes the other components like fitting, flanges, wall, bolt, gasket, special parts. So the combination of all these piping components make a piping system. So what is the role of a piping material engineer? So piping material engineer is responsible for quality of a material, creating a project pipe classes and various piping specification required in a project too. So why to create all these documents? So these documents are required to fabricate and test the piping system. If I want to build something, I should know from where I should build it. And once I build it, I have to test it whether it will be running as per the expectation or from the quality point of view whether it's running or not. So that's why the testing is important. So in few companies call this position as a piping material engineer. Few companies call this position as a piping specification engineer. So as I told you, when we say about the piping layout engineer, he mainly deals with the 3D modeling software like E3D. Previously, it was known as PDMS or S3D or different softwares. So there, the task of piping layout engineer is to route a line from one location to another location. But the pipe which is selected to route from one location to another location, it has to be of certain material, certain quality, certain requirements. Now, how should I know that which material I should know, why I should use, or what testing shall I apply on those material after I use, so that that material is suitable for the selected application. So there should be some guidelines, right? Everyone cannot follow their own guidelines. That is why we do have some global guidelines. And then we have some global institutions. They have created few codes and standards. So certain rules are mentioned in those documents. So in the engineering we do follow these documents so that we all are following some quality standards. So there are two terms. One is a code, another is a standard. So by definition, code is a group of general rules or systematic procedures for design, fabrication, installation, and inspection that are adopted by legal jurisdiction and made into law. So as I said, for the quality purpose, we have to follow something, and these are quality documents prepared by some agencies. Okay, so these are the set of rules and requirements which are the minimum requirement to be followed. Features in the covers in the codes. So general guidelines for the design, minimum engineering requirement for the safe design, and they indicate the reference standards. To give an example, everyone, the people who are working in the piping industry, they must have heard about the ASME B31.3. So generally, this standard we use for our chemical industry. So in that standard, so many different and as well as the complicated rules or the regulations are given that we have to follow when we prepare a piping material specification. Then we have a standard. So these standards are a document prepared by professional societies or committee which are believed to be efficient engineering practice and which contain mandatory requirements. So when we say that which are believed to be efficient engineering practices, so while before publishing this such documents, they have done a lot of research and development, a lot of testing, and then set some rules that if these rules are followed, then this material or this component is safe to use. So these are the additional requirement to the course. Okay, so at this moment, I will not go into too much of this because I know this is a complete theoretical portion, and frankly speaking, this has to be covered in a deep details. So obvious, in a short time, this is not possible to go in this standard, and just by giving something on the slide, it is not possible to explain also. But just to give an idea, there are two things: codes and standard, which gives some rules and regulations to prepare our documents. So the specification documents. So what are the advantage of working with codes and standard? Why we have to follow this? So they establish a commonality in engineering criteria, terms, principle, practices, materials, and process. So when I say about commonality, okay, so now as we know that if someone has the Apple phone, okay, their mobile charger is different, and if someone is using some another company Android phone, their mobile charger is different. So you cannot connect. If Android person want to connect a charger, he cannot take it from the user of the Apple mobile. So there we do not have any commonalities. And why sometimes this commonality is important? Because all over the globe you cannot set different set of rules or something. There are different rules, but majorly the standards which are followed are the American standards, which is the ASME standard. They help to establish a standard way of working. So whether the project is getting executed in India, or if it's getting executed in Saudi, or if it's executed in US or Europe. If you follow a same standard, global accepted standard, you have a standard way of working. They ensure build in safety, reliability, and continuity. So we must have observed that there are few cases of accidents, blast happen in the chemical industries, be it a chemical plant, small, big, catching of a fire for some equipment, the blast of the boiler. There are some serious accidents happen in the past, and unfortunately now also the few accidents are getting happened. So that is why the safety is important, and these codes and standard has put some minimum requirements. So if you follow those requirements, the safety of your system will be taken care. Just to give an example, um, uh, now we select a pipe. Okay, then what should be the thickness of that pipe? So there is one formula given in the code ASME B31.3. Based on that formula, we have to calculate a thickness. So in that formula, there are multiple factors like allowable stresses. So they have given, if you select a carbon steel pipe, then at this temperature, this will be the allowable stress, because they have done already the testing of the materials. So if we follow those values, those rules, then our pipe is suitable for XYZ design pressure and temperature. They minimize mismatches and promote interchangeability. So as I said, the mobile charger of Apple and another Android phone cannot be interchanged. Sometimes interchangeability is also important. They economize the system, reduce inventory, and ensure readily available backup from the market. So when all over the globe you are using the same material, and if you suppose you build a plant now, after 10 years you want to buy some part, some pipes or some walls, so it should be available in the market. It's like when we buy any four wheeler, any car, we always check what is a possibility to get the spare parts in the market. Unfortunately, if something is broken out, then and you have to wait for the spare part to be ordered from some another country, which will take 6 months or 8 months. Nobody would like to do that. So spare parts should be available just next to you immediately. So that's what our expectations are. They help in accumulation of knowledge. They help in avoiding reinventing the wheel again. So as I said, when some standards and some codes are published, they are published with a lot of backup, a lot of research, which is already done. And what we have to do as an engineer, we just have to follow those standards. We do not have to do any research or analysis, nothing. Certain rules are given and we have to follow that. And that's good for everyone. So as I said, interchangeability or the set of rules. The people who are seeing these, the people who are seeing this chart for the very first time, they might get confused. You don't know, you don't have to remember everything, but I will just explain you the first row as an introduction. Going into details of this it will take a lot of time, and this is not intention of our today's session also. So in general, we have the different materials like carbon steel, alloy steel, high temperature, alloy steel, low temperature, and the austenitic stainless steel. We do have another categories, but these are the majorly used. So, for example, let us take an example of a Samsung mobile. If I want to buy a Samsung mobile, I do not go to a shop and say that, okay, give me a Samsung mobile. I don't say that. I ask them for the specific version, or like I want A34. I want Samsung A34. I want Samsung M52. Okay. Or you also have the series S series, M series, A series. So you go and tell him the specific product that you want to buy. On a similar basis, if I want to buy, so this is example of different components used in piping. So let us take an example of only pipe. So if I want to buy a pipe from a market, carbon steel pipe. So I don't go to a vendor and say I want a carbon steel pipe. Okay. In general, when you want to use something at your home for the basic use, it's okay. But when you are using a product in the chemical industry, which is dependent on so many different factors, you have to be specific. So that is why, again, these are the global standard, ASTM standard, American Society of Testing and Materials. They have given some names or the tags to the certain materials. So if I want to buy a carbon steel pipe, it is called as a A. It means ASTM 106. This is some number they have given. Grade A, grade ABC. That depends on your the chemical composition of that material. So if I want to buy a stainless steel pipe, okay, then the main grade is ASTM A312. Main ASTM standard is A312. Within that, we do have a multiple grades: TP304, TP316, TP321, TP347. So just to give an idea, this is, I mean, if we add the molybdenum in TP304, it becomes TP316. And TP316 has a higher corrosion resistance property as compared to TP304. So this is how these materials are distinguished and called by certain names. Okay. Okay, I have to come to this part later on, but okay, now I'll select two. I know I think I'll come to this slide later on. So in general, if you want to see the material of construction, which are the materials which are used in a piping. So the main three categories are the metallic pipe, non-metallic pipe, and the lined pipe. In the metal also we have a ferrous and non-ferrous. Okay. Uh, I'm sorry. This non-ferrous should be copper, nickel, alloy should be here. I by mistakenly put it there. Uh, so in ferrous we have a cast iron, carbon steel, alloy steel, and stainless steel. When to use this, uh, it has to be explained in a detailed way. Non-ferrous comes copper alloy, nickel alloy, and other alloy. And in the non-metal, you have. I'm sorry. This three should under this non-ferrous. I by mistakenly put it here. In non-metal, you have plastic pipe, GRP pipe, glass reinforced pipe, FRP pipe, fiber reinforcement pipe. To give an example of plastic pipe, generally nowadays in a sanitary piping in our bathrooms, we use a white PVC pipe that you must have seen. But in the older days, there was no PVC pipe. They used to use a galvanized pipe, galvanized iron GI pipe, what they used to call. And also we do have a lined pipe. Okay, I will show you one of the photo for this. So what is the lined pipe? It is nothing but a metallic pipe, just common metallic pipe, but from inside some different material lining is given. That lining may be of the rubber or the PTFE. It depends on the application what we are using. Okay. So also, I mean, while continuing this session, I will try to show a few images or the few things from the Google, because if I just explain the things from the slide, it might get boring, and it is also not possible. I don't like to put everything on a slide and then just edit it out. A few times I'll go to Google and show you the images also. Now we have seen there are different type of materials which are available in the market.